Hello, my name is Satisha KM, lecturer, Electronics and Communication Department, Karnataka Government Polytechnic, Mangalore. I would like to welcome you to ARM Controller online class. Unit-1, ARM Embedded Systems and ARM Processor Fundamentals. In this session, we can discuss topic banked register, session number 8. In previous session, we discussed ARM processor block diagram. In this block diagram, we are having different subblocks such as register 5, that is R0 to R15. Next, we are having barrel shifter. Next, we are having arithmetic and logic unit. Next, we are having multiply and accumulate unit, address register, incrementer, instruction decoder, sign extension unit. We discussed one by one block diagram and we seen how data will flow from one block to another block. The arrow mark here showing is data transfer from one block to another block. Data flow from one block to another block. ALU has two input, that is here it is shown as A bus and here it is shown as P bus. One operand or one content is directly coming from register 5. Another content coming from register 5 through barrel shifter. Output is given to address register or register file itself. After calculating here, result will be stored at again register 5. Next, we studied CPSR, that is current program status register. Structure of CPSR. In CPSR, we are having mainly two fields. One is control field flag register. Another one is flags. In control section, first 5 bits are called mode bits. By setting this mode bits, we can change the mode of ARM4. Next bit is thumb bit. Next 2 bits are called interrupt mask bits. One is fast interrupt mask, another one is interrupt mask. In last section, we are having flag section. In that, we are having 4 flags. V means overflow, C means carry flag, Z means zero flag, N means negative flag. This is structure of CPSR. Total we are having 32 bits. In that 8 plus 4, 12 bits are used as a flag bits. Next we studied processor modes. There are total 7 processor modes are there. In 7 processor modes, one is non-privileged mode, that is user mode. User mode is non-privileged mode in processor code. Rest 6 modes are privileged mode, that is abort mode, fast interrupt request mode, supervisor mode, system mode and undefined modes. Total 7 modes are there. One is privileged mode, rest 6 are unprivileged. Privileged mode, non-privileged mode, user mode, rest all modes are privileged mode. In today's class, we can discuss topic banked register. In banked register, we can see the definition of that. Block diagram of complete ARM register set. In each mode, how many registers or how many banked registers are available, that one we can discuss. And next we can discuss with one example, that is changing the mode from user mode to IRQ mode. What are the steps are there? What are the registers are affected? That one we can discuss. After that, we can see multiple choice questions under banked registers. In ARM7, total 37 registers are there. Out of 37 registers, 20 registers are hidden from a program at different times. These hidden registers are called banked registers. Banked registers of a particular mode are denoted by a underline, and mode mnemonic. For example, abort mode mnemonic is ABT. FIQ means fast interrupt mode mnemonic is FIQ. For example, R13 in abort mode denoted as R13 underscore ABT. For example, R8 in FAQ mode is denoted as R8 underscore FAQ, etc. Now we move on to block diagram of complete register set in ARM. There are 7 modes are there in ARM core: user, system, fast interrupt, supervisor, undefined, abort. Out of these 37 registers, 20 are shown as shaded registers. These are called banked registers. Now we move on to each processor mode and how many registers, banked registers available in each mode. First we move on to user and system mode. In user mode, total 17 banked registers are there. From R0 to R12, general purpose registers. R13 is called stack pointer. R14 is called link register, that is having return address. R15 is called as program counter. Next we are having CPSR. In next mode, fast interrupt mode banked registers. In fast interrupt mode, there are 8 banked registers are available. That is R8, R9, R10, R11, R12, R13 is stack pointer, R14 is link register. Next we are having saved program status register, that is SPSR register. Total 8 registers are available in fast interrupt request mode. FIQ is mnemonic for this mode. Next, we move on to interrupt mode banked registers. In interrupt mode, there are 3 banked registers are available. Mnemonic for this interrupt mode is underscore IRQ. R13 is stack pointer, R14 is IRQ. Next we are having SPSR, saved program status register. In supervisor mode, there are 3 registers are available. One is R13 stack pointer, R14 link register, SPSR saved program status register. In undefined mode, again we are having 3 registers, banked registers: R13, R14, SPSR. Mnemonic for that mode is UNDEF. Total 3 banked registers are available in undefined mode. Abort mode banked registers. There are 3 banked registers are available. R13 stack pointer, R14 return address, it having return address. Next we are having SPSR, that is saved program status register. R14 is also called linked register. Now we move on to how processor will change one mode to another mode. The processor mode can be changed by two methods. You already seen CPSR having mode bits. In CPSR register, we are having 5 bits for mode. Mode bits, we are calling as mode bits. By writing directly to CPSR, we can change the mode by one mode to another mode. This is the first method. The second method is exception or interrupt. By hardware, when core responds to an exception or interrupt, by hardware using interrupt or exception, we can change the mode from one mode to another mode. Then, from what are the conditions to change one mode to another mode? Here the list is given. For reset, interrupt request, fast interrupt request, software interrupt, data abort, prefetch abort, and undefined instruction. So these many conditions occurs or exception or interrupt occurs, then mode will change to one mode to another mode. If exception or interrupt occurs, then the processor suspends the normal execution or stops the normal execution and jump to a specified memory location given by the vector table. For example, here you can see in this block diagram, if mode can changing from user mode to interrupt request mode, then R13 and R14 you can see here. In interrupt request mode, we are having 3 banked registers, that is R13, R14 and SPSR. This R13 and R14 in user mode copied to this banked registers. That is R13 is copied to R13 IRQ, R14 is copied to R14 IRQ, and the CPSR, the previous mode CPSR, is copied to SPSR. Note that SPSR can be only modified and read in privileged mode, but there is no SPSR available in user mode. In user mode, SPSR is not available, CPSR is available. Then, in which type of changing the mode, the SPSR is copied by CPSR. If mode change by the first method, that is program writing directly to CPSR, if this type of program change, then CPSR is not copied to SPSR. If program change by the hardware or exception or interrupt, then only CPSR will copy to SPSR. When processor is in IRQ mode, the instruction you execute still access register named R14 and R13. User mode registers R13 USR and R14 USR not affected by any instruction under interrupt request mode. A program still has normal access to other registers, that is R0 to R12. We can summarize what we discussed in this. We can summarize point by point. ARM7 has total 37 registers. Out of that 37 registers, 20 registers are hidden from a program in different times. These registers are called banked registers. Processor has 7 modes, total 7 modes. So in each mode, number of banked registers available is different. Here list is there. In user mode, there are 17 banked registers, R0 to R15 CPSR. In system mode also we are having 17 registers, R0 to R15 CPSR. In FIQ mode we are having only 8 registers, R8 to R14 SPSR. In IRQ mode we are having only 3 registers, banked registers, 13, 14 and SPSR. R13 is called stack pointer, R14 is called linked list register and SPSR or CPSR. In supervisor mode, we are having only 3 registers, R13, R14 and R15. In undefined mode also, we are having 3 registers, banked registers, 13, 14 and SPSR. In abort mode, we are having again 3 registers, 13, 14 and SPSR. Now we can discuss multiple choice questions comes under banked registers. First question. Number of hidden registers available in ARM banked register. Option A 20, option B 37, option C 17, option D 8. You can think of the answer for this. In ARM7, total we are having 37 registers. Out of those 37, 20 registers are called, 20 registers are hidden registers at different points. These are called banked registers. Therefore, there are 20 registers are there in banked registers. Question number 2. Number of available banked register in fast interrupt request mode. Total we are having 20 banked registers. Out of 8 registers are available in fast interrupt request mode. So answer is 8. Third question. While for changing from user mode to interrupt request mode, previous CPSR is stored in. First choice is CPSR, option B R13, option C R14, option D R15. While changing the user mode, interrupt mode from user mode to interrupt request mode, the CPSR is copied to SPSR. Here R13 is stack pointer, R14 is link register, R15 is program counter. The answer is A, saved program status register. Fourth question. Number of available banked register in ARM undefined mode. In undefined mode, how many banked registers are available? Option A 20, option B 37, option C 3, option D 8. Can think the answer or we can discuss the answer for this question. In ARM undefined mode, there are 3 registers are available in ARM banked register. Answer is C, 3. In next class, what and all topic need to discuss? In next class, we can discuss pipeline in ARM7 architecture. First, we can discuss the definition, what is the pipeline, and the building blocks of three-stage pipelining. Next, we can see the non-pipelined instruction process comparing to a pipelined instruction processing. What is the factor of increment the throughput in sequential and parallel for pipelined instruction processing? Next, we can see with an example, we can explain the three-stage pipelining of ARM7. Next, we can see the advantages of the pipeline. Next, we can discuss the topic disadvantage of pipeline. By this, we can end this session. Thank you.